Lesson 17.8, solid of revolution about a horizontal line. This is called disk and washer. First problem is a disk problem. The second one's a washer problem. What you've got to think about is creating a three-dimensional shape again because we're trying to find volume. So what they tell you is the region R is the area. It's enclosed by f of x, which is 2x to the 1/3 power, this cube root function. The horizontal line, y equals -1, which is right here. And then x equals 0 and x equals 7, so that gives us our lower and upper bounds for our x values for our integral. And then we're going to find the volume of the solid generated when the region is revolved about this horizontal line y equals -1. So what you've got to imagine is that this line is staying stationary, and you're taking this two-dimensional thing and spinning it around and around. Think about if this was on something and you spun it really fast, it would create this illusion to where it looks like this is all one big circular object or a disc. So it's creating all these circles all the way here, and we want to accumulate all of that to find the volume. And again, on Delta Math, once you see the answer and you use slider, you'll see all of these circles be able to slide all the way across. And so what I've really got is circles. Sorry, it looks like an oval, but I guess I should draw a circle. So if I were to take one slice out, and I need a radius, because area of a circle is pi times radius squared. And the radius is going to find this length from upper function minus lower. So we just need to do that the radius is going to be this f of x, which is 2x to the 1/3 power, minus the lower function, which is the horizontal line, y equals -1. So it'll be minus -1 or plus 1. So all I've got is from 0 to 7 of my area, which is pi times the radius squared with respect to x. Now what you could do is go ahead and take pi out since it's a constant and put it in front, but it's up to you how you want to do it. And then just put it on your calculator. Math 9. Oh, see, I already forgot to put pi. Let me do that first. Pi, and then you can hit times, or you don't even have to do that. Pi, and then 0 to 7. Put parentheses, so you can square this. 2x to the, I'll put parentheses around 1, divided by 3. Mine, I don't think you have to. Some of them you might need to. Plus 1, close parentheses, squared, with respect to x. Now, it takes just a second to load because it takes your calculator a little bit of work here. Total volume of this disc-like shape is 341.327. I just think that's so cool. All right, and then last one, the washer problem. We've got another two-dimensional, I don't know what made that, another two-dimensional region here. We've got f of x is natural log of x, and then g of x is a linear function. So this top one here is the natural log of x. And this one here is g of x, 1/3 x minus 1. Find the volume of the solid generated when this region R is revolved around the line y equals 6. So picture this now being our center point here. We're going to take this, which has space from here to here, and we're going to revolve it around and around and around, and it would create this open circle here. So every time it creates this circle within a circle, I'm going to draw it like this just so you can really see, creates a washer for each sliced cross-section piece. So you would want to do, since we're finding just the area of the outer, kind of like a donut, we want to do the radius to the outer circle. So you want to do outer circle or area minus the inner area. So you're subtracting the outer area minus inner area. So you're going to do two separate integrals. Okay, so let's set that up. We don't know our bounds here, so you're going to have to put these two functions in. So we got natural log of x and 1/3. I put parentheses around that just in case. X minus 1. Change my window. Let's go zoom standard. See what I can see. I'm going to zoom 0. See if I can do zoom to fit, maybe. See a little better. Yeah, should work. Okay. Find your points of intersection real quick. And you should get these two x values. And then be careful here. We don't necessarily want the line that's on top, but we want the line that's furthest away. So if I'm spinning this around, the biggest circle is going to be created by this linear function in 6. So I'm going to have that the radius 1 is going to be my 1/3 x minus 1 minus 6. Actually, let me back that up and reverse it. I do want above to below. So I do want this to this. So it's 6 minus this. Let me write that better. So radius 1 is going to be 6 minus 1/3 x plus 1, because I distribute the negative. So that would be 6 plus 1 is 7 minus 1/3 x. That's my first radius of my outer. So I'm going to do pi times radius squared. And then plus, I'm going to have the same, I'm going to write, just do this and this, same bounds. And now I want radius 2, which is the smaller circle, which is still going from 6 to this top line. So it's 6 minus natural log of x. So it'd be pi times 6, or of 6 minus natural log of x dx. And so it just, the most tedious part is just putting those integrals in on your calculator. So I'm going to go math 9 and put this in exactly like this. But I did forget pi, so I'll do that first. Okay. And I did notice one mistake that I didn't put on here is I forgot to put this squared. So again, it's pi times radius squared. And the first radius was my outer circle. So from the center down to the bottom line. And then plus pi times second radius squared, which was from center line to this top line, which was natural log of x. Make sure you're putting parentheses in correct, and I got 1,488.533.